All right, so let's take a look at a few examples on calculating slope at a specific point. Okay, so in this example, it says use the limit process to find the slope of a function at the specified point. All right, so here's my function, here's my point, and I want to find the slope at this specific point. Okay, so before we even start doing this problem, let me just give you a visual representation of what's going on, right? This is your rational function, and so if you remember how to sketch a rational function, right? The vertical asymptote, is x is equal to 3, and let's just quickly do a quick sketch. Okay, so x is equal to 3 somewhere over here. I'm not going to bother with the tick marks. And, if you were to plot some points, right, and in fact, the horizontal asymptote is y is equal to 0, right? If you were to plot some points, the graph would look roughly something like this. Okay, and what is the question asking? It says use the limit process to find the slope of this function, right, f of x, at the point 4 comma 1. So 4 comma 1, right, if this is 3, 4 comma 1 may be somewhere over here. So there's my point 4 comma 1. And what am I asked to do? I'm asked to calculate the slope. Right, what is this slope? Question mark. Okay, so again, I don't want to just go through the algebra without you understanding what are they asking me to do. They're asking you to find the slope at a specific point. And remember, right, conceptually, it's like, how do I find a slope at a specific point? If there's only one point, well, we take the limit, right, by calculating the slope of the tangent line. As the points get really, really close, as we make delta x or h really, really close to 0, right, it's the limit as h goes to 0. And so we're going to use our equation of our tangent line, which I have here in this video or in the previous notes, right? The slope of the tangent line is the limit as h goes to 0 of the slope of the secant line. Okay, so actually let's write that down. The slope of the tangent line at a specific point is equal to the limit as h goes to 0 of f of x plus h minus f of x all over h. All right, so there's a number of ways of doing this problem, right? I think in your textbook they plug in the point. As you'll see in the next example, right, you can find the equation of the tangent line first and then plug in the point at the end. Okay, so let's just plug in the point. The way your textbook does it is they plug in the point here first. So let's plug in at the point that we want to find the slope at, right? We want to find the slope at point 4 comma 1. So it's going to be f of 4 plus h minus f of x at this specific point. I'm going to plug in the point 4, f of 4, all over h. And so what this expression represents, right, is the slope of the tangent line at this specific point, 4 comma 1. Okay. All right, now all you need to do is evaluate what this is, right? Your difference quotient is the limit as h goes to 0 using all your limit properties and all your algebra skills. Okay. So if I want to calculate what f of 4 is really quickly, f of 4, right, is just 1 over 4 minus 3, which is 1 over 1, which is 1. So again, make sure you keep writing the limit as h goes to 0 until the very end. So this is just a minus 1 over h. And f of 4 plus h, right, I need to plug this guy into my function. So when I plug in f of 4 plus h, it's 1 over 4 plus h minus 3. Okay, 1 over 4 plus h minus 3. All right, now you have to practice your algebra, right? This is the limit as h goes to 0 of 1 over 4 minus 3 is 1, h plus 1, minus 1 over h, right? And now all you have left is a complex fraction and a limit problem. Okay, so remember how to simplify a limit problem with a complex fraction, right? We multiply top and bottom by h plus 1. All right, so distribute, right? H plus 1 times H plus 1, that's just 1. Now, here's the key concept right here. When you distribute -1 into this, right, make sure this is in parentheses. So this is minus H, right, minus 1 over H times H plus 1. All right, these guys are going to cancel out, right? The 1s are going to cancel out. And you're left with an H here and an H here. These guys will cancel out. And so you have a -1 over H plus 1, right? And now, right, on this particular line, right, you can plug in the value of 0. And you don't have to write the limit anymore once you plug in the value. So -1 is the slope at this specific point on this function. And so the skills that you need, right, is to calculate compute limits, algebra skills, and you have to understand the concept of, what does this slope of the tangent line represent, right? This represents the slope of the secant line, but when the limit as h goes to 0, right, if I take another point and, call the distance between this point and this point, h, if I make h really, really tiny, right, the slope of the tangent secant line becomes the slope of the tangent line, and now you can find the slope at a specific point. Okay, so that's the big picture, and of course this is all the algebra that's required to calculate the slope, right? And this makes sense, right? That slope does look like it's negative, and it's around -1. It's exactly -1. All right, so let's do another example that's really pretty much similar in concept to this one, except on the next example, they don't plug in the point, whatever point they have until the very end, but the concept is the same. Okay. So next example involves a radical function, and it says find a formula for the slope of the graph, then use it to find the slope at the specified points. Okay. So to find the slope of any particular function, right, at any point, again, I'm just going to use my slope of the tangent line formula. The slope of the tangent line at any point is the limit as h goes to 0 of f of x plus h minus f of x all over h. And so, let me give you a pictorial or graphical representation of what's going on first, right? It's saying find the slope of the formula, or find a formula for the slope of the graph. So this right here is your square root function shifted 2 units to the left, right, using my transformation. So here's my graph, and maybe we'll call this -2. Okay, so my graph is roughly going to look something like this, right? There's my square root function, okay? Right, it starts at -2, domain is -2 to infinity, right? And what I want to do is find the slope formula for any point. And once I have that slope formula, I can plug in these points, okay? So again, what is the question, right? It's saying, find the slope at 2, 2, maybe this is 2, 2. And what's the slope right there? Okay, and then 7, 3, maybe somewhere over here. I don't know. What's the point? What's the slope at 7, 3? Okay. So unlike the last problem, right, they plugged in the points in the beginning, right? They plugged in 2, 2, they plugged in 7, 3. I find that this way is a little bit more efficient, because once you find the slope for the graph at any point, you just plug in the point at the very end. Okay, so again, this problem just comes down to finding the slope, finding the limit of this expression using this function. And once you, practice all the algebra and simplify everything, you can just plug in the points at the end. Okay, so that's the only thing that's different from this example and the previous example. So everything goes back to the difference quotient, right, and calculating limits. So let's plug in limit as h goes to 0 f of x plus h, if I plug in x plus h into this function, right, it's going to be the square root of x plus h plus 2 minus the function, which is the square root of x plus 2. Okay, and now this just comes down to a limit problem. How do I compute this? Again, if you try to plug in 0, right, you're going to have square root of 2 minus the square root of 2, which is 0 over 0, which is indeterminate form, which means you have to apply some algebra. And so on this problem right here, again, keep writing that limit as h goes to 0. I know that's not something that you probably enjoy doing. So if you remember, right, to simplify a radical, you can multiply by the conjugate of the numerator. And the conjugate of the numerator, in fact, I'm going to run out of space here. I'm just going to shift over here. The limit as h goes to 0, the square root of x plus h plus 2 minus the square root of x plus 2. So basically just copy this line twice because I'm running out of space here. Multiplied by the square root of x plus h plus 2, right, plus the square root of x plus 2. Okay, top and bottom, right? Because you need to multiply by 1, it does not change the value, right? This expression right here is just 1. Okay, so this looks very intimidating, right? But again, everything comes back to your algebra skills. That's why I keep harping on your algebra skills. Students who struggle in calculus often struggle with algebra, okay? So in your numerator, right, you have a minus b times a plus b, right, which a minus b, or a plus b times a minus b is a squared minus b squared. So if I square this, right, this just becomes x plus h plus 2 minus this guy squared is just x plus 2. Okay, so I'm going to show you an extra line. This is square root of x plus h plus 2 plus the square root of x plus 2. You can now do some canceling, okay? So the limit, in the numerator I should say, the limit as h goes to 0, this is minus x, this is minus 2, right? So minus x is going to cancel out this x. Minus 2 is going to cancel out with this 2, right? All you're left with is an h. These h's will cancel out. You're going to get the limit as h goes to 0. 1 over the square root of x plus h plus 2 plus the square root of x plus 2. Okay, now if you plug in 0, right, if you substitute 0, you're just going to get root x plus 2 plus root x plus 2. And so my final answer for the slope of the tangent line is 1 over, actually I'll do the plugging in right here so you can see, 1 over x plus 2 plus 1 over x plus 2, right? Again, if I plug in 0 over here, right, this is root x plus 2 plus root x plus 2. So if I add these two together, the slope is 1 over 2 square root of x plus 2. Just a couple things. So this is the slope of the tangent line of this particular function. Maybe we'll call that part 1, right? You don't need to simplify your radical, okay? The whole point of simplifying your radicals is really just to work on your radical skills. But if you just leave it like this, right, this will be perfectly valid, okay, on, calculus exam, on a, in the back of your book when you're doing your homework, or, I'm sorry, what I mean is when you're taking an AP exam, they don't really expect you to simplify the radical unless it's stated specifically, okay? So again, what does this represent? Conceptually, this represents a slope at any point on this particular curve. And now to answer this, right, use this function formula to find the slope at the specified points. All I need to do for part A, right, this is for part 2, so it's just a plug in. So the slope, so m tan at we'll say 2 comma 2, right, is m tan 1 over 2, right, all I need to do is plug in the x value of 2. 1 over 2 root 4. Sorry, this is 4. Square root of 4 is 2. 2 times 2 is 4. The slope at 2 comma 2 is 1/4. Okay? And then for part B, right, m tan, the slope of the tangent line, at 7 comma 3, right, all I need to do is just plug in the x value. That's all I need to do. 1 over 2, 7 plus 2. Square root of 9 is 3. 3 times 2 is 6. So the slope at this specific point is 1/6. Okay? So this problem really just generalizes the formula first, right? This is the slope at any point, and then you can just plug in the points at the end.